Hello, my name is Sean, and today I'll be going over symbolic hexabuttons. Now this module looks similar to blue hexabuttons, with the big key difference is that there's a number written on the center button. So I'll write that down. So we're going to need all the symbols here. Each of these symbols is basically reference to a number, in which case that button in specifically is going to be assigned that value. So first we have a V, which is going to be a 5, which I'll write down as 0, 5. Next we have the 3 lines, which is 2. The curly thingy. Now there is definitely a lot of characters here. Here's another one. This is going to be 25. Next one is phi. I think that's phi. If I remember correctly, this it's going to be 6. Next is pi, which is going to be 29. And then finally, this one, which is going to be 11. Perfect. So, without further ado, let me explain this module. This module is similar to one of Speaking Evil's modules, that being of Simon Stores. So, the number written on this enter button is basically our N0. So this is definitely N0 here. And basically pressing the center button will cause the non-center buttons to perform 6 swaps. Each swap is assigned a value of f of n minus 1. So basically that swap is basically assigned a value of whatever this function is using n of 0, or basically 259 in this situation, as a initial value, let's just say. We're going to look up the operation used for each swap in the tables below to get a value for that swap. And each time you get a value for it, we're going to module it by 1,000. Important note is that here's basically our single swaps. Very straightforward. And then there's also things called double swaps, which allows us to do 2 functions. In the case of that, basically 2 buttons will swap at the same time. Or 2 pairs of buttons will swap at the same time, I should say. And then for triple swaps, that just means that 3 pairs of buttons are swapping all at the same time. So, without further ado, we're going to record these swaps, and the way I like to do them is by labeling each button as 1, 2, 3, 4, 5, 6 in that order. So, let's begin. So first, we have a 3 swapping with 5, then a 1 swapping with 6, 1 swap 5, 2, 6, 3, 4. Then we have a 2 with 3, 4 with 5. Then we have a 1, 2, 3 with 5, 4 with 6, and then a 2 with 3. Now, if you did not get all of that, we can press the center button again to get us back to the first stage, at least the initial stage. And at this stage, we can't press any buttons, just to clarify. You hear me clicking the button. Only in that second phase, we can actually click any buttons. So let's press it again. So first was 3 with 5, so these 2, and then 1 with 6. Then 1 with 5, 2 with 6, and 3 with 4. Yep. And then 2 with 3 and 4 with 5. And then 3 with 5 and 4 with 6. And then 2 with 3. Alright, that seems in order. As you see here, that basically, with this module, there's a balancing issue. So, one of the balancing that it does is that there will be exactly 3 single swaps, 2 double swaps, and a single triple swap. And another thing about this is that the time, at least the pauses between each one, are different. The bigger the swap is, which is a triple swap, the longer the pause time is going to be. So that allows the diffuser to relay their information all in one go. So let's begin. So first, 3 swapped with 5. So what I'm going to do first is I'm going to apply the swap first. So that means these two values swapped with one another. So here's 9. I forgot the other. It was 25 and 5. Okay, 29 and 25. So these places swapped with one another. And then we also have 259 as our function. So this is going to equal, let's see here, if we find 3, 5, which is going to be somewhere right here. Here's our 3, 5 function. This is the function of 2 times our n, which currently now is 259, plus X-ray. Now, there are 2 other values, being X-ray and Yankee. And all you have to know about this is that X-ray is equal to the sum of the 2 values, and Y is equal to the difference of the 2 values. And A and B in this case is the 2 values assigned to the buttons that swapped with each other. So we have to do, let me get out my calculator. We have to do X-ray, which is going to be our 29 plus 25, the 2 values that swapped. And since this is an X-ray, we're going to do a sum of them. And then we're going to add this to 259. And then we're going to multiply this by 2, which is going to give us 600, which is going to give us 626 as our first thing. Cool. And then we have to use the previous value as our next thing here. So this gets 626 here. So now, basically, we have 1 6 swapping with one another. That's going to be right here. This time it's going to be 2 times, well, 626 here, plus Yankee this time. Now let me do the swap first. So this is going to be 11, and this is going to be 5. And now with Yankee, as you recall, it's going to be the difference between the two. And usually I like to do difference as a way of doing the higher number minus the smaller number. So this is going to be 6 plus 626. That's going to be 632. And then we need to multiply this by 2, which is going to be 1,264. But as you recall, we need to module each of these values by 1,000 every time. So basically this one gets 264 instead. Next, we're doing this triple swap over here. So first let me apply the triple swap. So this is going to be 25 and this is going to be 11. This is going to be 5 and this is going to be 2. And finally this is going to be 6 with 29. Now for a triple swap, if the triple swap is present in the list below, we're going to use function O. So usually I like to find 1 with 5 here, if I can find 1 with 5, which we do have a 1 with 5, and that's doing 1, but 2 is swapping with 4, which can't happen. So it's not present in the list, otherwise we're going to use function P, which is right here. So we're going to take the minimum value, which is what that min equals, to basically 1/5 of 264. Now do this. There we go. That's easy. 5 of 264. We have 2/6 of 264 and 3/4 of 264. So we have to apply all of these functions as well. So first we need to do 1/5. So 1/5 is this one right here, which is going to equal to n plus 2 times the X-ray. So 1 and 5 swap, that's going to be 25 plus 11. That's going to be that. And we need to times this by 2. Gives us 72 plus our 264. This is going to be 336. And now we do 2, 6 here. So let's see if I can find 2, 6 is just right there. So this is going to be 2 times 264 plus Yankee. So let's go over here and basically apply this. So we do, let's do 2 times 264. And then we're going to add basically a parentheses I'm going to do here, just for the sake of it. Actually, no, I didn't have to do a parentheses. So the difference between 5 and 2 is going to be 3. It's going to be 531. Okay. And then we are going to do 3, 4 as the last one here. 3, 4 is over here, which is going to be simply n plus x. So it's going to be 264 plus x. Now we're going to do 264 plus x-ray, which is going to be these two. This should be 35, but I'll do 6 plus 29 gives us 299. And so now we take the minimum value between the three, which is going to be 299. Now we have to apply 299 to this. So first, let's do the swaps. So 2 and 3 swap. So it's going to be 6 and 5. And then we're going to do 4 and 5. So 4 and 5. Now we got to do everything here. So for double swaps, in the case of double swaps, take the two positions that did not swap with one another. So the two swaps that didn't swap with one another is top left and bottom right, which is going to be this one right here, and apply this function to it. So we have 2, 3, and 4, 5. We have 299, 299. So we're basically taking the difference between the two values. So let's first do 2, 3. So let's see if I can find 2, 3 here, which is right over here, which is going to be the difference between 299 and x-ray. So if 299 minus x-ray, if I can find here, which is going to be 2, 3, which is going to be the addition of these two. So 5 plus 6 is 11. So minus 11 is going to be 288. Next we have 4, 5. So let's see here. 4, 5 is over here, which is going to be this. So this is going to be 299. So we do 2 times 299, get this, minus the sum of this. So 4 and 5 will be here. So that's 3940, and that's going to be 558. Now we do basically the difference between the two. So we could do 558 minus 288 gives us 270. But we're not just done yet, because now we got to times this by 2, which gives us 540. Next we have 540 with 3 and 5 and 4 and 6. So let's see here. 3 and 5 indicates these two, right? Yeah. So 29 and 5. And 4 and 6 indicates these two. So the ones that didn't swap is top left and top right, which is right here. That's going to give us this function right here. Now, it says always to round down in this case. So we're always doing some integer division with this. So we're going to take 3, 5 and 4, 6 over here and do 540, 540. So let's find 3, 5. If I can find it, which is over here. So it's going to be this here, which is going to be 540 plus X-ray. So 3 and 5 is going to be 29. Yeah, we can do this. So we have 540 plus 29 plus 5. That's just all the sum of all that. And then we're going to times all of this by 2. And make sure to module 1000 whenever we do a function. So this is only going to be 148. Next we have 4, 6 being our next one, which is over here. So it's going to have this function. This is going to be 540 minus 2 times X-ray. So this is going to be, X-ray is going to be 2 plus 11. This is going to be 13. So this is going to be 540. So 13 times 2 is 26. So 540 minus 26 is going to be 514. And then we can do this, 514 minus 148. It's going to be 366, but we're not done yet. We have to divide this by 2, which gives us 183. All right. And then finally 2, 3, which is going to be 29 and 6. And so 2, 3 is right here, is going to be this function right here. So 183 minus X-ray, which is going to be 29 plus 6 is 35. Then 183 minus 35 is 148. All right. Now comes into the final part. We have to now press all the non-center buttons in such a way that the values assigned to each of them is in the same order of the values assigned to each swap. What does that mean? So the first swap, so we need to order these swaps from least to greatest in such a way. And such, basically all these buttons have been assigned, I would say, unique values. And so, because, so let's see here. So 148 seems to be pretty low. So I'm going to do something like this to order them, right? So this is the lowest. I'd say 183 is the next lowest. Then 264, then 299, then 540, then 626. So then if we were to order these scores, and I'll bring it down a little bit. Like so. And let me grab this. Let's see. Like so. There we go. So this is 2. I'm going to order at least the values in this order from least to greatest. So you can kind of get a picture of what I'm doing. So these are the values from basically least to greatest. And what we need to do is press the values in such a way. So first we have 6 as our first one, such as this is the biggest value. So we need to press the 29 first because that is the biggest value. Then we need to press the third value. So 1, 2, 3, that would be the 6. Then the fourth highest value. So that's going to be 1 from 6, that's going to be 11. Then the fifth highest value, 1, 2, 3, 4, 5, that's going to be 25. Then the second, then basically second here value, which is going to be 5, and then 2. I don't mean fifth highest. I meant like we have to press the highest, which would be the 6th lowest in such a way. since I did it like so. So, this is practically the order that we have to press the buttons in, because this is basically the highest value, being the 6, because the first swap was definitely the highest value that it was. If this makes any sense of what I'm doing right now. So we have to press the button that is assigned to 29, and as we're doing the swaps here, we make sure of keeping track of which button is which. Now, so I'm going to press 29, the 6, which is over here, the 11, which is assigned over here, and say if I press the wrong button and press the 2 instead, well, it won't give us a strike until we press all 6 buttons, which makes this module even more insidious, as it tells. And of course, if you're pressing buttons in the wrong stuff, like so, you can press the center button to reset your input. Of course, when you have no input and you press the center button, as you saw, it will basically go back to that initial stage. And of course, allowing you to get your swaps again. So, let's do this. And hopefully I'm right. 11, 25, 5, and 2. I hope all of you enjoyed this tutorial. Until next time, guys, keep talking and don't explode.